story of hydrogen as an energy carrier begins within the broader context of human advancements in energy utilization. The Industrial Revolution, fueled by the discovery of the steam engine by Thomas Newcomen in 1712, marked an important shift in energy consumption. The primary energy source during this time was mineral oil, stored in the Earth's crust over millions of years. Over time, raw oil and methane became dominant energy sources, reflecting humanity's reliance on fossil fuels. In 1860, global energy consumption was estimated to be 5 times 10 to the power of 12 kilowatt-hours per year. By 2008, this figure had skyrocketed to 1.2 times 10 to the power of 14 kilowatt-hours per year. In 2023, global energy consumption reached an estimated 172,000 terawatt-hours per year, and still growing. Despite this growth, around 80% of energy production remains tied to fossil fuels, contributing significantly to carbon emissions. The annual release of CO2 into the atmosphere stands at 7 times 10 to the power of 12 kilograms per year, while terrestrial plants and oceans together absorb approximately 4 times 10 to the power of 12 kilograms per year. This imbalance results in a yearly CO2 increase of about 0.4%, highlighting the need for sustainable alternatives. Hydrogen, with its clean combustion that produces only water, offers a promising solution to the energy crisis. Its potential as an energy carrier aligns well with global goals to reduce greenhouse gas emissions and transition to renewable energy sources. Below you may find a schematic overview on the hydrogen cycle, where solar and wind energy are used to produce hydrogen. In this cycle, renewable electricity generated from solar panels and wind turbines powers an electrolyzer, which splits water, hydrogen oxide, into hydrogen H and oxygen O, through a process called electrolysis. The resulting hydrogen can then be stored in tanks as a compressed gas or liquid, transported via pipelines or special containers, and used in a range of applications, such as fuel cells for electricity generation, hydrogen combustion engines for transportation, industrial processes like steelmaking or ammonia production. When hydrogen is used either in a fuel cell or combusted, the only byproduct is water vapor, closing the loop with zero direct carbon emissions. This cycle represents a clean and sustainable energy pathway, aligning with global efforts to decarbonize energy systems and reduce dependence on fossil fuels. The hydrogen cycle is a cornerstone of future green energy infrastructure, enabling long-term energy storage, grid balancing, and low-carbon mobility solutions. The early discoveries of hydrogen include its first identification by Henry Cavendish, 1731 to 1810. In 1766, Cavendish published precise measurements of the weight and density of an inflammable gas, which he later burned in 1781, producing only water as a byproduct. This observation laid the foundation for understanding hydrogen's role in chemical reactions. By 1787, Antoine Lavoisier proposed the name hydrogene, derived from the Greek word hydor, meaning water former. In parallel, other scientific breakthroughs related to gases unfolded. In 1783, the Montgolfier brothers demonstrated the use of hot air balloons, successfully flying animals over Paris. A few weeks later, Pilatre de Rosier and the Marquis d'Arlandes became the first humans to fly, covering a distance of 9 kilometers. Around the same period, Jacques A.C. Charles, better known for Charles's law regarding gases, identified hydrogen's lightness compared to air, further expanding its scientific significance. The late 18th and 19th centuries saw remarkable progress in hydrogen-related technologies. Laplace and the heat of combustion. Investigations into the heat produced during combustion advanced the understanding of energy transformations. Nicholson and Carlisle, 1800. Their pioneering work in electrolysis marked the beginning of hydrogen production by splitting water into hydrogen and oxygen using electricity. Johann Wolfgang Dobereiner. In 1823, he developed a gas lighter using hydrogen, demonstrating a practical application of the gas. Sir William Grove, 1839. Known as the father of the fuel cell, Grove created the first gas voltaic battery, a precursor to modern fuel cells. Ludwig Mond and Charles Langer, 1889. They coined the term fuel cell and laid the groundwork for hydrogen's use in energy conversion. The 20th century saw hydrogen's industrial and energy potential gain significant attention. Lurgi process and steam reforming. The development of these methods allowed for large-scale hydrogen production, primarily for industrial applications. Justy, in 1955. The idea of hydrogen as an energy carrier was formally suggested, emphasizing its role in addressing energy sustainability. Contemporary applications and developments. Today, hydrogen is used in various sectors, including energy storage and fuel cells. Hydrogen fuel cells are integral to electric vehicles, providing clean energy without greenhouse gas emissions. Industrial processes. Hydrogen is essential in ammonia production, refining, and metallurgy. Aerospace. Liquid hydrogen serves as a rocket propellant, enabling space exploration. Green hydrogen. Advances in electrolysis powered by renewable energy have paved the way for green hydrogen, a zero-emission alternative. The potential of hydrogen to transform energy systems globally is immense. By addressing challenges such as production costs, storage, and distribution, hydrogen can become a cornerstone of a sustainable energy future. As we continue to innovate, the legacy of pioneers like Cavendish, Lavoisier, and Grove serves as a testament to the enduring promise of hydrogen as a clean and efficient energy carrier. To consolidate your understanding of hydrogen's role in the energy system, you are now invited to complete a short quiz. This quiz will review the key concepts introduced in this module, including the historical development of hydrogen as an energy carrier, key components of the hydrogen value chain, environmental and economic implications of hydrogen use, current and future applications of hydrogen technologies. Please proceed to the quiz to test your knowledge and reflect on the material covered.